The AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia, and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.
Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Thank you, Anna. Hello, everyone. Good morning, good afternoon, good evening from me as well. I am Guilherme Martinez Roura from the International Telecommunication Union, and I would like to welcome you all for joining today's AI for Good webinar on cognitively assistive robots for dementia care, organized by the ITU. This session is part of the AI for Good robotics programming track, exploring how AI-powered robots are helping to unlock our human potential and advance the United Nations Sustainable Development Goals. We have a distinguished set of panelists today, but as always, we are counting on you, the participants, to help create a very interactive session. Without further ado, I would like to introduce our moderator today. His name is Frank Rudspik, and he's Associate Professor at Dalhousie University. Frank, welcome, and the floor is all yours.
Thanks very much. So I'm just going to say a few words before we introduce our speakers. So I wanted to also wish a good afternoon and evening or morning, as the case may be, to all the guests, the panelists, and other participants from around the world. So I am Frank Rudspik. I'm an Associate Professor of Computer Science at Dalhousie University in Halifax, Canada, and it's my pleasure to moderate today's webinar on cognitively assistive robots for dementia care, which is a crucial part of the AI for Good initiative. So today's webinar is about harnessing the transformative power of artificial intelligence and robotics to tackle one of the most pressing challenges of our time, which is dementia care. So there's currently about 60 million people affected by dementia globally, but this is projected to surge to about 150 million by 2050. So we really urgently need innovative, compassionate, and also effective solutions to reduce caregiving burdens while also maintaining the quality of life and outcomes for patients. So this webinar is going to explore cutting-edge integrations of AI with robotics and intelligent autonomous systems that really promise to revolutionize dementia care and care in this space generally. So this is very important, not only for the patients, but also for the caregivers and clinicians. And if these solutions are deployed widely, this could really potentially transform the landscape of long-term care. So this is how today's session will proceed. So we have 5 distinguished panelists who are leaders in their respective fields. So one by one, they will delve into various aspects of this burgeoning field from their own perspectives, from ethical considerations to the challenges and opportunities of implementing these technologies in the real world. So one by one, they're going to make an opening presentation in turn, and I'll introduce each of them in turn. And then during this time, we'll be accumulating questions from you, the audience, on the neural network social platform during this time. And then after everyone has presented, we will be asking some of these questions during the subsequent Q&A session at the end of all the presentations. So I really encourage each of you to engage actively in the discussions, since your insights and your questions will provide unique perspectives on the talks you're about to hear, and also on the complex and promising field of AI and robotics for good. So with that out of the way, I'd like to introduce our first speaker. Mr. Tom Stevens launched Tombot in 2017 to help seniors with dementia. Prior to Tombot, Tom and his partners built ACT Litigation Services into a major worldwide e-discovery company, which was acquired in 2011 by Discover Ready. So Tom has spent more than 35 years in senior positions in the high-tech field, having obtained a Master's of Science in Management from Stanford Graduate School of Business, and also a Bachelor's of Arts in Political Science from UCLA. And we're very happy to have him here. So take it away, Tom.
Thank you so much, Frank, and so grateful to be included on such an esteemed panel. Good morning, good evening, good afternoon to everyone who's attending today. So I'm Tom Stevens. I'm CEO and co-founder of Tombot, and this is Jenny. Jenny is a fully interactive robotic emotional support animal, and Tombot robots will be the first to be registered medical devices and remote safety and health monitoring platforms. As Frank was sharing, I've been in the high-tech world for about 35 years. I exited a startup business with my two Tombot partners in 2011. That same year, my mother was diagnosed with Alzheimer's dementia, and that started a series of very difficult events. Pardon me, get to share my screen here. That started a series of very difficult choices that I had to make on my mother's behalf. The first was coming to terms with the fact that she could no longer live independently. My parents had divorced when I was a teenager, and while my father remarried, my mother never did, choosing to live by herself all those many years, and it became a source of pride for her. After her diagnosis with dementia, we realized she could no longer safely live on her own. And so I made the decision to move in a caregiver, and that made her very upset. She felt like this was a major loss of her independence. The second very difficult decision I made for her was taking away her car keys. Every time I visited, there was more body damage on her car, and of course, it was never her fault. So taking away her car keys not only was a further restriction on her independence, she now had to ask for permission and get assistance to go anywhere. But neither of those decisions affected her as profoundly as the third decision, which was the day I realized I needed to take away her dog for safety reasons. Every day, it was angrily, where's my dog? Why can't I have my dog? When am I getting my dog back? And really just out of purely selfish reasons to salvage my relationship with my mother, I started looking around for substitutes for live animal companions. But everything I bought and brought home for her, she absolutely hated. And I realized that there was a gap in the marketplace. That launched me on a multi-year research and education journey, which culminated in that master's degree from Stanford. And along the way, I learned that my mom's story is shared by tens of millions of others with dementia and tens of millions more who are pre-dementia, mild cognitive impairment, and many of whom will ultimately develop into dementia. So a very large problem, very serious problem. And I thought that we might have some insights on how to approach this. First of all, persons with dementia most commonly have something called behavioral and psychological symptoms of dementia. Those symptoms include loneliness, depression, frustration, in my mother's case, hallucinations, and violent anger. Additionally, over 80% of seniors in nursing homes are thought to suffer from chronic pain. Historically, these two classes of symptoms have been treated with medications that we now know are quite dangerous. The behavioral and psychological symptoms of dementia have been treated with psychotropic medications, which include anti-anxiety, antidepressant, and antipsychotic medications. And not only do these medications turn seniors into zombies, many carry grave health risks, so much so that the Centers for Medicare and Medicaid Services here in the United States prohibit their use in long-term care facilities under most circumstances. And for chronic pain, historically, we've used opioids to treat that. But if you've been reading the press at all for the last decade or more, you'll know that opioids, while still a best practice for treating short-term acute pain, are very dangerous for treating long-term chronic pain. So doctors, patients, family members have been pretty desperately looking for alternatives to these two classes of medications to manage the symptoms commonly associated with dementia. This is a very well-researched area. Over 150 peer-reviewed studies have been published to date. They show that where a person with dementia can form a robust emotional attachment to an object, traditionally that object is a human baby doll or a stuffed animal, that person receives a great deal of relief from their behavioral and psychological symptoms and a corresponding reduction in need for the psychotropic medications. The problem here, however, is very few seniors care for and are able to form the necessary emotional attachment to those traditional objects. Research on robotic animal therapy show that they show significant benefits, including benefits similar to what we see with live animal therapy, and they reduce the need for pain medications. However, existing technologies are very expensive, and there are some questions as to whether these benefits that we see in short-term small studies will actually persist over time. This space was invented by an excellent robot out of Japan called Paro. It's a robotic seal in the lower right-hand corner of the screen. But once again, it's a very expensive robot and has been sold in very modest numbers since its inception in the early 2000s. I was armed with this information when I launched the company, and the first thing I wanted to understand is why any of these objects worked in the first place. And the leading theory is that they stimulate the production of endogenous oxytocin. Endogenous means it originates in the brain as opposed to something you would get through an injection or a nasal inhalation. Oxytocin has been demonstrated to reduce stress, reduce anxiety. It's fundamental in the formation of emotional bonds, and it's also been shown to interact with our internal opioid system, which means it's a natural pain reliever. Oxytocin has been shown in mothers giving birth to babies or breastfeeding. It's seen in parents bonding with adopted children, so that genetic connection is not required. And it's also seen in humans interacting with live animals. Most of the research there has been done with dogs. However, for most seniors with dementia, these relationships are not safe, practical, or readily available. So the question became, could we develop a better emotional attachment with a synthetic object, something that consistently stimulated endogenous oxytocin, not just upfront, but over time, but also be available at a price that most people could afford? We conducted 3 rounds of customer studies to try to understand what their preferences would be in emotional attachment objects. The first hypothesis that we tested was that seniors with dementia would prefer animated objects to non-animated objects. In this study, we tested a plush toy animal, a human baby doll, and against a couple of robotic toy objects, 1 dog and 1 cat. And what we found was that 100% of those seniors with dementia that could still indicate preference preferred the objects that moved over the objects that didn't move. However, what we found is that there was a lack of identification with those objects. We would hear things such as this is really cute. I think my grandson might enjoy this, or maybe my great-granddaughter would like playing with this. So even though they liked it and were entertained by them, they didn't identify them as something being appropriate for themselves. The second round of customer studies tested the hypothesis that persons with dementia would prefer realistic appearance and realistic feel to the objects. And in this study, we tested realistic prototype versus a cartoon type. When you think of cartoon, think of Disney. So oversized eyes, oversized facial features, something that we find endearing in animation. However, close to 100%, 96% preferred the realistic objects over the cartoon objects. But the most frequent objection we heard there is that they didn't like the animations. They felt that they were mechanical and not naturalistic. Also, interestingly, that an additional study question that we looked at is, would they prefer a robot over a live animal? And close to 100% would. That surprised us. We found that there were multiple reasons, but they had already made the decision not to have additional live animals in their lives. And they felt that a robotic animal would solve many of their objections to another live animal. And then the third study looked at the hypothesis that they would prefer realistic animations and realistic behaviors. We created Jenny here that you see on screen and compared that to the leading toy robotic animal. And we found, once again, close to 100% preferred the realistic appearance, realistic texture, and the realistic behaviors of our most. And then through those studies, we're actually able to determine what the minimum viable product features would be to be able to stimulate endogenous oxytocin. We teamed up with Jim Henson's Creature Shop, the wonderful artists behind Muppets and Sesame Street, to do all of our artistic design. And with their help, we're building what we believe to be the world's most realistic robotic animals. They are designed specifically to stimulate emotional attachment through the production of endogenous oxytocin. And then once that emotional attachment's in place, we become a unique and unobtrusive platform for monitoring that senior for safety and health purposes. So a little bit about Jenny. She's rechargeable batteries. So one of the things we learned is that non-rechargeable batteries tend to be very difficult, particularly for seniors to change out. Secondly, she is a computer. So like any computer, including your smartphone, she's fully upgradable from a software standpoint. We come with a companion smartphone app that allows for a number of initial configuration settings, including changing the name of the robot. And that allows people to call the robot whatever they like and have the robot respond accordingly. And I'm going to stop sharing my screen for one moment here. I'm going to be a close-up of Jenny. So she's covered with sensors. She can feel how and where she's touched. She can tell the difference between a simple touch, a slow caress, a vigorous pet, and being held. Once again, she responds to voice commands. She can feel herself being moved. She comes with a light sensor, so she knows if it's dark in a room, she shouldn't bark, and a number of other sensors to help her understand her environment and display a behavior that's context appropriate for that environment. And then lastly, our go-to-market monitoring capability will be for monitoring sundowning syndrome, which is one of the most common symptoms associated with persons with dementia. So thank you very much. I look forward to hearing your questions later on in this presentation, and I'll pass it back to Frank.
Thank you for the amazing presentation and the live demo also. And yeah, I also echo, please send your questions our way. Our second speaker is Dr. Janet Wiles. She is a professor in human-centered computing at the University of Queensland and leads the Future Technologies thread of the ARC Center of Excellence for the Dynamics of Language, or co-EDL. So Dr. Wiles received her PhD in computer science from the University of Sydney and completed a postdoctoral fellowship in psychology. She has 30 years of experience in research and teaching in machine learning, artificial intelligence, bio-inspired computation, complex systems, and importantly, social robotics. And we're also looking forward to hearing her presentation. Dr. Wells?
So thank you. Can you see my screen?
Yep, looks great.
Okay. Yeah, thank you very much for the invitation to speak today. I'd like to start by acknowledging the Turrbal and Yagara people who are the traditional owners and custodians of the lands where I'm presenting from, and I'm presenting from Mianjin, which is Brisbane, Australia. So my lab designs social robots and language technologies, and in particular, we research how we communicate with robots. So I want to start with this question. Why
I believe there's an issue with Janet's connection.
Seems that way to me too. Just when she's going to ask an interesting question.
Yeah.
Would you like to wait and see if the internet fixes itself, or should we maybe reshuffle?
Yeah, let's see. Janet, can you hear us? Ah, okay, looks like she's reconnecting.
There we are.
Hi, Janet, welcome back. You're on mute. Hang on, I'll just ask you to unmute there.
Okay.
Okay, perfect.
Okay. Can you see my screen again?
Yep.
Yes.
Still looks.
Okay. So,
Go. Mhm.
yeah. So I was talking about why we don't have stair climbing robots. And it turns out that in practice, they're heavy, they're expensive, they're complicated to make, and they're complicated to repair. And people who are in wheelchairs would prefer ramps. They're cheaper, they're easier, they make access possible for everyone. Strollers, push bikes, and suitcases on wheels. So when we think about engineering challenges, you know, stair climbing wheelchairs, in a sense, they have tunnel vision, or their designers do. They're looking at the symptom, a person who can't walk upstairs. So I want to introduce a term that may be familiar to some of you, but perhaps not to others, and is beginning to come into engineering. And I think it's a really important term to know. It's called a disability dongle. So a technology that addresses symptoms with what turns out to be an unusable solution is called a disability dongle. And the definition comes from Liz Jackson, who's a disability advocate. A disability dongle, it's well-intended, elegant, yet useless solution to a problem we, people with disabilities, never knew we had. And I want to ask you to think, how many of us have a drawer full of useless technologies? So one of the things is robots that are designed for people with dementia are rarely designed by them. These robots often address perceived deficits. They don't necessarily build on people's strengths, and they're not problems or solutions identified by the people themselves. So to design robots that people will want to use, our design processes need to change. And human-centered AI places humans at the center of design. So this is a transformation that's coming across AI as a whole, and also human-centered robotics. So this diagram here is from Schneiderman. And I asked ChatGPT, just for fun, to give me a definition of human-centered AI. It said HCAI places humans at the center of design and deployment. In practice, it involves a multidisciplinary approach that brings together ethics, psychology, sociology, and human-computer interaction, and it aims to enhance our quality of life. It's a pretty good definition. I also asked it to come up with a list of AI technologies to support older people living with dementia at home. And our project is particularly in the early stages of dementia, where people still live in the community. And in Australia, that's more than 95% of people living with dementia, because people live with dementia for 20 years or more in many cases. So the list that ChatGPT came up with: memory apps, smart homes, virtual reality, telehealth, wearable devices, social robots, and customized music. Sounds like a pretty good list. The thing is, most of this technology is not actually used by older people. It's bought by their children. It reduces the children's anxiety, but it doesn't help the person with dementia or their carers unless it is integrated into daily life. So, for example, some of the social robots that people talk about, one of their touted advantages is to remind people to take their medicines. So if you've ever been a carer, and my mother lives at home with dementia, you'll know the real problem is not a reminder to take the tablets. You can put reminders on your phones, all sorts of places. The question is, were the tablets actually taken, or were they taken twice? Robots don't have that kind of real world knowledge yet. So I want to describe two projects in this presentation to illustrate algorithm-centric and human-centric design approaches to dementia technologies. So as I said, the vast majority of people in Australia live at home in the community, by themselves or with family or carers. And one of the main reasons that people leave home for institutional care is a breakdown in communication. So people have trouble finding words. So in this first project, we started designing a system, this is more than 10 years ago, to help people find the right words to support communication. And this slide shows a typical clinical monitoring system. It's got a research component, so there's some monitoring of the person, Bluetooth to a phone that goes to the internet. There's a clinical warehouse. You might de-identify the research, the data, and use it in research. So there are many kinds of metrics that computer scientists and others develop to use. So if you look at the GPS, it records how a person moves through their community. During dementia, the life space that people move through reduces over time, typically. We worked on a smartphone that records speech to take samples of speech or for conversations. We looked at how people interact with other people or with technology, so interaction analysis, how people interact in groups, so who talks to whom in groups, and a whole variety of tools. So there's one that just looks at how people interact with pauses, and actually you can detect dementia just from the way in which people pause in conversations. So a couple of years into our project, an occupational therapist joined our project and recruited 12 people who live with dementia and 17 care partners to join a living experience experts panel. And the first question is, what do they think of this idea? Think to yourself, what do you think of this idea? It turns out our living experience experts hated the idea. It was intrusive. It destroyed the social moment that it was intended to support. So having a technical device come up with words for you in the moment when you're trying to communicate actually doesn't work very well. Some people thought it was demeaning. Some people thought stigmatizing. In hindsight, although we did a lot of really good research and developed a lot of useful tools, as something that supports people living with dementia at home, it was symptoms focused, not strengths based. So it was about as useful as a stair climbing wheelchair in practice. Okay, so I want to tell you a second project. So the project, we call the project Florence, and the project pivoted at that point. Our living experience experts became part of every aspect of the project. They helped us choose what we were designing, evaluating. They became co-presenters and co-authors of our papers. The way we interact as a team had to change to accommodate their diverse abilities. Dementia affects everyone differently, so you have to design for one, is a phrase that people in design use. This is quite a complicated slide, and I won't talk through all of it. What I want you to see is that there are a whole range of different design approaches that became part of the process. We started using participatory activities, trying to understand the problem space better, design and development, metrics and technology, and then outputs. There's a whole variety of different applications and tools. So the kinds of insights revealed through participatory design included a phrase, "make my day go better." And that became the informal motto of the project. Others were, use my current strengths, help people connect. And the concept for what we eventually built came from Dennis, who's one of the panel. Dennis is a retired computer programmer. He has early stage dementia. He lives in the community. He programmed a series of reminders throughout his day with Star Wars themes. So I think there's a myth that people with dementia can't do anything. Actually, Dennis is a counterpoint who has many capabilities that are really useful. Now, Dennis wanted a way to manage all his information at home. He knows that his disease is progressive. Over time, he wants to remain in control himself, but he wants to grant access to parts of his information to different people, his doctor, his physio, his wife, his family. It's not possible to build the kind of system Dennis wants based on standard technologies. So with Dennis and others on the team, we've been designing an AI-powered database that contains the personal data that an individual wants to record about themselves. So it might be the significant people in their lives, daily events, music they like, sports teams, parts of their life story that they like to talk about. So they also wanted ways that they could see and correct their data. They wanted to tutor the system. The system that we ended up designing has micro access permissions that can change over time, and that's under the control of the person themselves or their care partners. Privacy and cybersecurity is supported at every level of technology design. I don't know how many people are aware, but if you don't build it in right at the beginning and at every level, it's very hard to bolt cybersecurity and privacy onto technology that's already been designed. So we call this an intimate knowledge ecosystem. So in summary, what makes Florence different is the participatory design process we follow, and that has resulted in designing an integrated system with hardware, software tutoring, and data custodianship built into every component. So Florence ended up being not just one device. It has at its heart a personalized knowledge bank, which supports an ecosystem of communication devices. And the idea is to build on the kind of devices people have in their home already and the ways in which they interact with them. People on our living experience expert panel didn't necessarily want to use smartphones. Many of them will use tablets, some use computers, but they wanted devices with knobs and buttons. So what we designed, you can see here a music or radio. Inside it has a smartphone that interacts with the internet, but people in their own homes can interact just with one knob if they want to. There's a daily diary which shows what's happening next, and there's a photo album that families can, using the internet, project their photos onto. But from the person in the room, it's very simple, and it just has a series of knobs and buttons. Inside, it's actually a tablet. So this is a concept for people living at home the way they want, doing the things they want. In this, we've got Daisy. She's one of our personas, and she can sit there reading a book and drinking coffee, and all the devices support the way she wants to live her life or communicate with her family and carers. So she's not disturbed by the technology, and she's in control. So just to summarize, insights from the project: technology should be usable. It should support the identity and the daily life and the valued activities of people. People said it needs to work in my environment, which means not teaching people new technologies, but introducing technologies that they already know how to use, even if what's inside the box has more capacity than those devices would have had in the past. Devices need to make sense. They need to be chosen by people themselves. They need to connect people and not isolate them. So technology should not increase stress. It shouldn't cause conflict. And a lot of our modern technologies do when they're introduced into inappropriate settings. Technology should not be unnecessarily complex. It shouldn't reduce people's independence. It shouldn't be easily lost or broken. When we design, we shouldn't focus on the symptoms, but rather how to support people through the strengths that they have for the goals they want to achieve. It should not increase the safety risks. It shouldn't share people's data without their permission, and it shouldn't exclude them either from the process or the family or from their own lives. So just to finish, I want to finish with thinking about the model of the human that we have as technology developers. And that includes the model of people living with dementia who aren't just patients, they're people. So if we think about the psychological needs, there's a model we've been developing with our social psychology colleagues that we call the social self-determination model. And the three big concerns of people in daily life is the individual autonomy, a person's own competence, and their relatedness to others. And these will change over time with dementia, and they also change when we introduce technology into people's lives. But it's not enough just to look at the traditional idea of one person, one piece of technology. Actually, we need to think about how the technology also changes the collective autonomy, the collective competence, and the collective relatedness of people. And that requires a whole new way of thinking about the impact of our technologies and bringing more people into the design and the development process and evaluating our systems as we go ahead. So thank you, and I will finish here.
Thank you for your amazing talk, Dr. Wiles. We're going to keep on sending us your questions, and we're accumulating them for a question period at the end of our 5 speakers. The third speaker is Dr. Mujan Ghafourian, Assistant Professor at the Department of Systems Design Engineering at the University of Waterloo in Canada, and co-director of the Social and Intelligent Robotics Research Lab. Dr. Ghafourian obtained her PhD from Pennsylvania State University in 2017, and she was the inaugural Wes Graham postdoctoral fellow from 2018 to 2020 at the David R. Cheriton School of Computer Science at the University of Waterloo. Over to you.
Thank you very much for the introduction, Frank. Hello, everyone. Today I'm going to present some of our research on developing social robots and socially assistive robots for supporting people with dementia and caregivers, with an emphasis on making and the importance of making them emotionally intelligent and personalizable. As a very brief introduction, social robots can have different appearances, different functionalities. They may look like animals, they may look like humans, or they may just not look like an animal or a human, but have social capabilities to interact with their users. And also they may be stationary, they may be able to move in their environment. So there are a lot of different types of robots that we can use depending on the application area. And they can communicate with people through verbal and nonverbal behaviors, for example, by showing gestures, emotions, through facial expressions, or even lights. And they are a good candidate for supporting people in the healthcare domain because they can be, like many other technologies, personalized and adaptable. They can be connected with other types of sensors, such as health sensors, to monitor people. They are going to be perceived as non-judgmental unless they're programmed otherwise, and that is a big benefit for some applications, for example, supporting mental health or other application areas that people might prefer to interact with some entity that is non-judgmental. They're good at repetitive tasks. This makes them very interesting to be used for people with dementia and for supporting caregivers. And also they're enjoyable to interact with, and they have the physical presence that some of the other technologies may lack. In a recent review that we did, of course, these numbers are very quite old, so I'm sure that they're increased now. But looking at where social robots have been actually evaluated with people with dementia and caregivers, they have been mostly used in the context of therapy for providing, for example, pet therapy or music therapy, or as companions for people with dementia, or to increase their engagements with each other, or again, with the technology. But one area that I'm very interested in and has seen limited attention is supporting activities of daily living, so providing cognitive support for activities of daily living. And the emotions and personalities become important here, especially because to support people, to be able to help them, instruct them to do actions, emotions can play a big role in making the connection with people. Emotions are generally shown to improve social capabilities of robots. They can increase the feeling of presence, providing more companionship. They can improve interactions with robots. They provide an additional context for interaction. They can increase enjoyment and acceptance, and also effectiveness of robots in many domains based on the studies. And it becomes important for people with dementia because it's shown that regardless of the stages of dementia, if people have had a life journey, they would always remember how it felt to be at each of their previous social roles, even though they may forget what their role is currently at the moment of interaction. So if someone has been a mother and manager, they will always remember how it felt like to be in those roles. And when interacting with caregivers or assistive technologies, if they feel that they are the manager, or if they prefer to be treated as a manager, and a caregiver or a robot goes and orders them to take your medication, it can lead to a range of negative emotions and reactions and can negatively affect quality of life and interactions with caregivers. So it is important to understand how to support people with dementia, how the technologies and social robots can convey a message in a way that it aligns with what people expect it to do. And then how can we also implement these on different robots?
You should take your medication now. Could you please take your medication?
And this is an example of two different ways of showing the message from the videos. I hope the sound was clear. So there are two application areas specifically that I wanted to briefly talk about. One is on supporting caregivers that we are working on. We have been following user-centered design methods and participatory design here. We talked with professional caregivers who interact with multiple people with dementia at later stages of dementia at care centers. And they all told us that this component of adjusting their behavior is very important. They interact with over 20 people with dementia daily, and they said they have to know how to live in 20 different worlds to be successful and have successful interactions. But this training is currently missing. So this is something they learn through trial and error and due to negative interactions they have. So we started co-designing an application with them to provide that cognitive support on suggesting how to interact with each individual and how to bring this emotional component in their interactions. And the social robots here can be highly beneficial in providing role-playing, in playing roles to show them how to implement these interactions in real-life environments. The other application area is for supporting people with earlier stages of dementia to stay at home longer, to provide cognitive support with the goal of improving their quality of life. We talked with caregiver and people with dementia, asking what type of cognitive support they require, and they can use a social robot with. And they said they need, most of them actually emphasize the importance of the cognitive support in providing instructions and reminders on daily activities. And daily activities can be from taking medications, from just reminders on when to drink water, when to eat, as well as how to prepare a specific meal. And based on that, we have designed a social robotic system that connects a social robot for interactions, for guiding people, as well as a mobile app to provide another type of modality. The robot is also made to act as companion by providing jokes, getting involved into chit chat, and also has different personalities that people with dementia can customize. And here we have also, as a team member, an individual with lived experience of dementia who has joined our team as a co-designer and is commenting on how to move forward with this. But I emphasize on the importance of emotions. It's a very difficult thing to approach because as humans, we don't know, it's very hard to explain how we show emotions. And when we show emotions and how to create the contextually appropriate emotions. Our emotions differ a lot based on who we interact with, based on the context, and it's finding models that can generate contextually appropriate emotions is very important, but very difficult. In a recent study, we saw that although having appropriate emotions can really improve interactions and cooperations with the agents, if we show inappropriate type of emotion that is not matching the context, it can negatively influence the interactions. The second question that I try to address is how do we then design these emotional displays on different types of robots that may have different types of appearances and capabilities in a way that they can be conveyed correctly so the users can actually understand the type of emotion that the robot is trying to show. Similarly, looking at agent personalities, how do we define an agent's personality and how can we adjust their personality in a way that they can meet the needs of the user? For example, if I showed you before, if an individual thinks that they're the manager, how can the robot act as if how can the robot adjust its personality in a way that it meets the needs of that user? For that, we have been also looking at the affective component of personality with some promising results. Again, the next question is, how do we actually implement these personalities on the robots? So these are some of the brief challenges that my research team is trying to tackle. I will stop here and I look forward to the questions and discussions afterwards.
Thank you so much. So moving right along, our fourth presenter is Dr. Arshia Khan. She is a professor at the University of Minnesota, actively engaged in advancing the emerging field of neurorobotics through her research endeavors. So her work entails creative fusion of neuroscience, robotics, and engineering with a particular focus on human-robot interactions, autonomous behaviors, and intelligent sensor systems. So Dr. Khan, yeah, you want to share your screen? Perfect. Whenever you're ready.
Thank you so much for the introduction. Hello, everybody. I'm Arshia Khan, Professor and Director of Graduate Studies in the Computer Science Department at the University of Minnesota, Duluth. And Dementia and Elderly Care Robotics and Sensing is the name of my lab. In short, we call it DECAS. So today I'm going to talk a little bit about my work, what I do, and then I'm going to share a study that we actually just recently finished over summer, where we used a robot to apply some cognitive intervention, and I will be sharing those results, which are really amazing. So to quickly go over some of my projects, I've helped design an intelligent dementia-friendly living space through the Bold Ideas grant, designed an intelligent pillbox that communicates with the robot and helps with medication delivery, robot-assisted cardiac rehab after open heart surgery to help people who've had open heart surgery get out of bed and manage their medications and their diet. Bipolar disorder management, robotics in aid of children with autism spectrum disorder. We got some really good results with that, where the children loved interacting with the robots. In the HRI and neuroscience domain, we are exploring Uncanny Valley. One of my students is working on that. We are exploring robot acceptance in elderly care, compliance and reciprocity with the social humanoid robot. And I'm extremely passionate about encouraging women in computing. So we are also looking at gender differences in problem solving using EEG and EDA. So currently, we have programmed the robots to be able to deliver a variety of therapies and offer engagement activities to the elderly and people affected with dementia. We are employing artificial intelligence, wearable sensors, and using wearable sensor and spatial sensor data to be able to predict neuropsychiatric episodes. Tom was talking about the BPSD. This is the same thing by tracking and monitoring physiological and other types of data. Music and dementia care, we actually found a biomarker for memory recall recently. There's a lot of work that we are doing. We're developing a gossip bot where we are using gossip to help encourage people to do things as the disease progresses. And one of the major tasks that we are working on is robots helping with daily living activities and much more. I'm working with the Department of Human Services to bring robots to the tribal communities across the country. Music interventions, we are doing a lot of things with the music. Feel free to ask me questions afterwards. One of the things that I have been experiencing is that a lot of nursing homes, assisted living, and elderly care facilities have reached out asking for robots. But when they hear the price tag, they sort of are disappointed. So one of the things that my lab we all have been working towards for the last 1 year is trying to build a robot that will actually cost less than $10,000. So it'll be a few years before we are able to accomplish that, but we have been working for the last year. Currently, I have 16 robots deployed in 8 different nursing homes of the Monarch Healthcare Management. They have been extremely good research partners. And these robots have been able to work with help improve social well-being, emotional well-being, physical well-being, functional well-being, and cognitive well-being. And that is the part that I'm going to focus on in this talk here. We have IRB approved for this, and all the media that I'm showing today has been consented. So the research question is, can human robots affect cognition? And we finished a clinical trial over the summer, and what we found was that we could actually help improve cognition between 2 and 4 points when tracked by MoCA, which is a Montreal Cognitive Assessment tool. And this was across all the interventions that we performed. We gathered data from 2 different nursing homes, and I will be sharing that data. So we had a total of 35 consenting participants. Some of them were by power of attorney and some were self. And then we performed the MoCA on them, and we realized that only 21 of them had a MoCA score above 12, meaning anybody below the score of 12 would be severe dementia, and my IRB at that point wasn't for severe dementia participants. So we recruited 12 for the cognitive intervention and 9 for the other type of intervention. And this intervention was applied twice a week for 7 weeks for a total of 14 sessions. So. So the data that we gathered for this, we did pre and post studies because we could not do a control group. Initially, we went in with the intent of using a control group, but given the limited number of participants and the issues that we faced, we eliminated the control group and instead just did the pre and post. So we did the quality of life, the PANAS, the MoCA, the geriatric depression scale before the 7-week intervention and after at the end of the 7-week intervention. And every time we did the therapy, we did a BMIS, which is a brief mood introspection assessment. We did it before every intervention and after every intervention. And during the session, we also gathered the electrodermal activity data using wearable sensors. So the BMIS is typically a 16 mood adjective checklist. Very soon we realized that our nursing home residents weren't up for doing a 16 question survey before and after every intervention. So we shrunk it down to 4 moods, which was happiness, anger, fear, and sadness. And we performed a paired t-test on that, and we found that our p-value was highly significant, which demonstrated improvement of mood after the therapy. So the BMIS was, of course, self-reported, and so we weren't satisfied with just that. And then we started looking at the EDA, the electrodermal activity data. And typically, electrodermal signal is decomposed into phasic and a tonic signal. Phasic is the fast changing, as you can see in this image on the right. It's the sharp peaks that you see. It's essentially a skin conductance response, whereas the tonic is the slow moving, it's the skin conductance. So we gathered this data. We extracted the features from these interventions, and when we plotted the average tonic mean of baseline versus the therapy, you can clearly see there was an improvement. It wasn't just the BMIS data, the self-reported data, the EDA data also demonstrated the same, that we were actually able to improve their mood, and it was evident from the electrodermal activity data. And then we plotted the average phasic mean of baseline versus the therapy over the sessions. And as you're aware, as I mentioned, the phasic is the quick, sharp responses to the stimuli. So this graph is very representative of that. Also, our therapy sessions included music, it included cognitive exercises, and it included physical exercises and also some relaxation techniques. So when the EDA was dipping below the baseline, it meant that we were successful in reducing their stress, calming them down, essentially. And we did the paired t-test on that. And again, we found highly significant values here. So baseline tonic means versus intervention tonic means, baseline phasic mean versus the intervention phasic mean. And then we did the mixed ANOVA. So we took the phasic mean and for each gender over the sessions, and the phasic, as I mentioned, is the sharp, instant, immediate responses, and we did not find anything with that, which was as expected. When we did the phasic mean of therapy, on the other hand, for each gender, the mixed ANOVA showed that the differences between the genders are significantly correlated with the phasic mean, which was amazing. As you can see over here, the blue, the teal color is the male participants, and the coral is the female participants. And then we did the tonic mean of baseline for each gender over the sessions. We did the mixed ANOVA, and again, we found that the gender was highly correlated with the tonic mean for baseline. Now, notice this graph, you can see the men are highly conductive, which we need to go back and explore more. Why was their conductance higher than the female participants? So this was just the baseline that we were looking at. There was no intervention or anything going on at that time. And then when we did the tonic mean of therapy for each gender over the sessions, again, we found highly significant correlation between the genders and the sessions. And then you can see just in the first session, it's negating what the remaining data demonstrated, and we attributed that to the novelty effect when we first brought the robots into the nursing homes. So to summarize, mixed ANOVA, phasic mean, baseline session, gender, we did not find anything, but we found gender to be correlated, highly correlated in the remaining data sets. To conclude, the study design challenges, recruitment, attrition, control group was a challenge to do. Data gathering wasn't so easy because the residents, they weren't really up for doing any activities on days. Assessments was a big challenge. If we did any assessments that tired them out, we couldn't do anything after that. Trying to be consistent. I have a large team of students, and trying to maintain consistency across the students was a challenge. I had to train them a lot and go through with every one of them. Non-responders, some of the participants won't respond to the electrodermal activities. That was a challenge. Administering MOCA was a big challenge. And then, need for consistency again. MMSE was easy, but it is not as accurate as the MOCA. There was the novelty effect, of course. So thank you so much for listening to me, and feel free to ask me questions about my past studies or any of the other things. Thank you.
Well, thank you. That was great. So finally, our last presenter is Dr. Wendy Rogers. Dr. Rogers is a Kahn Professor of Applied Health Sciences at the University of Illinois in Urbana-Champaign, and a certified human factors professional. She's also a director of the McKechnie Family Life Home and Health Technology Education Program, program director of CHART, and director of the Human Factors and Aging Laboratory. So we're looking forward to hearing your presentation.
Wonderful, thank you. It's very nice to be here today. I'm going to talk about a project that is called Stretching Their Reach, Robotic Support for Older Adults with Mild Cognitive Impairment, Early Alzheimer's, Dementia, and Mobility Impairment. So thinking about a range of needs that older adults might have for assistive robot support in their home. This is a project that is a collaboration with a company called Hello Robot that designed the robot, and also a life plan community that's nearby to campus called Clark Lindsay Village. And they have support for older adults who live independently, have assisted living needs, and also they have a memory care unit. I briefly want to talk a little bit about the evolution of robots. So we've been working in this space for quite some time, and one of the exciting things to see is that the cost of robots are going down, the components and the weight of robots are going down. And we've talked a little bit about the importance of thinking about robots that will ultimately be affordable, either in an individual person's home or in places like Clark Lindsay Village, where one robot might be able to serve multiple people. And so the Personal Robot 2, the PR2, my colleague Charlie Kemp and I started working with back in 2010. This robot weighed 500 pounds and cost approximately $400,000 US. And it could do a lot, but it was expensive and heavy. And so one of the things that Charlie's tried to do in his company is to think about how do we capture the capabilities of this robot into a much more affordable robot that's more maneuverable, that has possibly fewer safety concerns. And so his company, along with Aaron Edsinger, they've designed a robot called Stretch. Let me just show you a very short video of Stretch. And this is in the home simulation space we have on the University of Illinois campus, where we're able to test out some of these robots in the context of the home. So you see how Stretch can be easily maneuvered in relatively small spaces. And it's just a simple demonstration here of delivering a bottle of water to me. The key is that it's not as heavy as larger robots. It has contact sensitivity, so if it comes into contact with a person, it will bounce back, much like an elevator door or garage door. It weighs less, and it's ready for development and autonomy. So it's programmed in open source There are codes that are shared that can be used across different groups. And I'll show you at the end a slide of all of the different universities and companies that are starting to use the Stretch robot. We've been focusing on the Stretch robot to provide support for home tasks. So things like delivery of an item, turning on a light, reaching, opening cabinets, doing things in the home environment. And Stretch can be controlled with a remote controller, with a game controller that you hold in your hands, or with an interface so that a care provider could be controlling the robot in an older adult's home, for example. And so one thing we're very interested in is what are the capabilities and needs for a robot like Stretch to support individuals in their home environment. And as I mentioned, we're focused on individuals who have mobility impairments as well as cognitive impairments. So first, let me show you some of the ideas that are being generated by our older adults. So much like other speakers, we really pay close attention to engaging older adults in the development of our research. We're interested in what their needs are and designing the robot to help them. So listed here are some of the thoughts that have come up from our older adults with mobility impairment. So using Stretch to deliver items to them, to reach for items that are either high or low, because those are falls risk. And if we can reduce falls risks, people are able to stay in their own homes longer. Also, maybe to schedule reminders for them, to provide social engagement. So you can see Stretch in this image is holding a tablet where we can do video conferencing. Older adults who had upper body challenges also mentioned things like helping them with dressing, doing zippers, putting on jewelry. And then, of course, something maybe that all of us would like our robot to help with: housekeeping, making the bed, sweeping, and so on. We've also been collaborating very closely with a partner. His name is Henry Evans. Henry has quadriplegia, and he is a true participatory design partner. So we have put the Stretch robot into his home every summer for the last 3 years, and he is helping us design routines to enable him to do things like feed himself. So you see that he's controlling the robot here. He has a reflector on his glasses, and he can use his thumb so he can actually select items on the screen. And he's helping us to figure out things like what he needs to do with the Stretch robot: feed himself, scratch an itch, turn on the lights, and so on. And we're working also with an occupational therapist who's helping us to design the tools that Stretch can hold. And then if you look to the right, you see the interface that Henry is using. He's helping us to determine what are some autonomous routines that he can teach Stretch to remember, so that next time he wants to feed himself, he can just say, okay, Stretch, come next to the bed. Or for Stretch to learn the layout of the home and where the light switches are, and so on and so forth. Now, let's think about when we're working with people who have cognitive impairment. How do we engage them in giving us their ideas about what the robot might be useful for? And so one of the nice things about having the McKechnie Family Life Home is this research facility gives us the home environment where we can bring them in and expose them to the robots in a safe environment. The first thing we do is we show them a video. So here is a participant, and as somebody else mentioned, we have approval for sharing and their permission for sharing their videos. So they first come in and they watch a video on the TV about what the Stretch robot can do. So it's very safe. They're just watching it. They're getting an understanding of how this robot might work in a home environment. Next, we have them observing the robot from afar. So here, the participant is watching one of our research assistants use Stretch to help her put the groceries away and put other things away in the kitchen. So you see the distance, and the participant can observe what the robot can do in a safe way. Then we have the robot interact directly with them. So the robot delivers a bottle of water to them, or engages in a video conferencing session with them. So we are videotaping them and watching their reaction, but then also interviewing them about what do they think. We have them do a think aloud as the robot is moving about the space. What do they think about that? What are their reactions? And so on. And so we're starting to get some really good insights from them about how they could imagine using this kind of robot in their home. So things like safety monitoring, turning off the range, or medication management, also social engagement, and then having family members check in on them. So if you are a care provider for somebody with Alzheimer's and you're working, perhaps it's your mother or your spouse, you're away, you can check in on them remotely and have the stretch robot be able to move about the space, notice maybe there's a hazard on the floor, pick something up that has fallen, clean up if something has been spilled, deliver medication. So there are a number of tasks that a family member can do remotely, or a professional caregiver. So family care partners, but also professional caregivers. And then they also mentioned things that might be cognitively engaging, so watching videos or playing games on the tablet. Now, I mentioned we're also partnering with Clark Lindsey Village, and at their facility, there are multiple kinds of contexts and environments. So here are a few pictures from personal apartments. And the first thing you see is there's a lot more in these apartments than in the life home, right? The maneuverability is going to be more challenging for the robot, but there's so much potential. So we're going to be putting the robots into Clark Lindsey this summer and exploring potential benefits for both the residents and the staff. And this is critical, thinking about who the different stakeholders are. So for residents, having Stretch be able to deliver things to them or do things for them could increase their autonomy, could enhance their connection to a remote caregiver, enable them to maintain their privacy without sacrificing security, and then assist with everyday activities. Now, for the staff, it might enable them to remotely connect with the residents, do a wellness check for different apartments, and be able to support multiple residents with this single robot. We're also exploring the potential for these congregate living areas. So there's something called the greenhouse home, which is a new way of doing long-term nursing care. It's designed to look and feel like home. You can see the picture here. It's common areas where multiple residents can socialize and eat, and it's meant for them to feel like they're in a home environment. But these are for people who do have challenges with memory, so Alzheimer's disease or other types of dementia. So again, we have potential for the residents, enhancing their autonomy, retrieving items, providing safety support. So some individuals with Alzheimer's forget that they need to use a walker. So as soon as they get up, Stretch could deliver the walker to them. There are also a number of benefits for the staff. If you can have Stretch doing some other kinds of tasks like cleaning or delivery, the staff can spend more time conversing and building relationships with the residents. It might also reduce physical burden and their need for multitasking. So I want to emphasize something that I think other people have mentioned. When we're doing this kind of research, it really takes a team. So the University of Illinois group here, my colleague Raksha Mudar is an expert in neuropsychology, Harshal Mahajan is a bioengineer, Samuel is an electrical engineer, and the other students are graduate students and undergraduate students who love getting involved in this kind of project. We're also working with the staff at Clark Lindsey, and then the faculty staff members at Hello Robot who are intimately involved in the research that we're doing and designing and making changes to the robot as we're going along. And we all have these shared goals. So I mentioned that the Stretch robot is starting to be used in a variety of different places. I'll leave this slide up for a moment. Search in there for a university or a healthcare system or a company that might be near to where you are. And if you're interested in working with the Stretch robot, this is an opportunity for potential partnership. Thank you for listening. I look forward to your questions, and I like to also thank my team because without them, none of this would occur. Thanks very much.
Thanks. That was also amazing. I'm wondering if, because we're going into the question period now, if maybe the panelists would like to become visible. Now, actually, also, we've received a small number of questions directed for specific speakers, but given the time and the fact that I think we're now supposed to move into this neural network social page, it might be a good idea if you have a question for a particular speaker to engage with them in that environment. And for now, I thought we could ask a question sort of to the whole panel. And anyone is free to sort of chime in as they please. And that question is, I think all of you are kind of doing really important work. And a lot of it has to do with sort of deploying these solutions into the real world. But that also means that all of you have encountered sort of challenges or roadblocks to deployment. And I'm wondering if there's anything that you see currently happening or that you wish would be currently happening that would really facilitate a smoother transition of these technologies out of the labs and into like more widespread deployment in the real world. So for everyone to just chime in, feel free to. Tom?
Well, I can certainly add to that. I think the biggest barrier to success here is the lack of funding for commercialization of products. There is grant funding for academic research. There's grant funding for basic R&D, but there's a lack of funding available in the private investor world. And it's a little bit of a chicken and egg situation that until these markets become robust, until robots like Jenny or Stretch Robot are out there in significant numbers, there isn't going to be a lot of enthusiasm for investing in those spaces. So I think that's probably the biggest barrier, as Dr. Rogers and others mentioned, that the cost of these robots to deploy are coming way down. And certainly the potential for AI to make these robots more effective is coming along, but it's very early days, very, very early days, and we're taking baby steps at this point.
Yeah, I'll add to that. I was thinking the same thing, that we're funding, so the project I described is a small business innovative research grant, which is targeted to businesses, which is one great opportunity to pursue. But I think where we need to see more is support for more implementation science. Like, get a number of people mentioned the challenges of, well, what happens after the novelty wears off? What are the long-term benefits? What are the larger scale benefits for different types of people? And so having funding support for those kinds of studies, I think, is really going to help us move this field forward.
I would agree with both Wendy and Tom, and I think, having more infrastructure and more financial support, I feel like I'm constantly writing grants. I wish I could be devoting that time to research instead of sitting and writing grants, but without grants, the lab won't run. So it's a constant battle to try and make the ends meet with the funding that we have and applying for further funding. So
I agree with everyone. And sorry,
go ahead, Mujan.
Well, I had some delay, I think. Please go ahead, Jenny.
Yeah, I was just going to say, the other thing that I think we need is for people who are living with dementia coming up with solutions themselves to really understand more what people are doing in their own homes. So some people, like vacuum cleaning robots, but it's a trip hazard. How do you organize your home so that it's safe? And I think there's what Asha was saying about funding. I think we need funding not just for the clinical sides of dementia, but also the social sides, particularly, as I mentioned, 95% of Australians living with dementia live at home. And yet there's very little money that goes to the occupational therapists to actually work with people living at home in the kind of solutions that come from the people themselves. And then how do we link them up with, teams like Wendy's or mine, where, you're trying to understand and support people's strengths and support what they want to do, rather than just looking at the clinical symptoms and the weaknesses.
So I agree with everyone. Something I wanted to add was informing people with dementia and caregivers and everyone about what are the capabilities and limitations of the robots, because sometimes people shape these ideas of how they work based on movies, and based on that also it affects perception of the social robots. For example, some of the issues we see is that they may see it as a replacement for human, but they are intended to actually fill in the gaps in providing support. So it's important to also inform people about what are the advantages, what are their capabilities, what are the limitations, and what they actually aim to achieve, and what type of support they can provide, because that really affects evaluations. The people we get to help with evaluation of the robots usually they self-select themselves into the HRI studies, and it's important to reach out to a larger group of people who may have different perceptions and preferences for the robots.
Amazing. I wanted to just say that despite the fact that we've heard 5 very unique and excellent perspectives on this burgeoning area, it's also clear that everyone has a very kind of clear and common vision for the way forward. I think there's a lot of agreement, despite the fact that everyone's kind of working on like really novel, distinct areas. Technically, I think we're 5 minutes over time, and I know that the ITU wanted to provide some closing remarks also. And I wanted to give everyone in the audience time to interact with the wonderful speakers in the neural network platform to ask your other questions. So I'm going to ask if I think the AI, the colorful AI wheel, has anything they want to say before we move to the next step.
No, it's Julian. It's absolutely fine. We just play the outro video with our virtual avatar, Anna, that thanks the audience.
Okay, perfect. But before we thank the audience, I also want to thank these amazing presenters. And it was an honor to meet, I think, most of you, and hear your perspectives. And I look forward to also chatting in the neural network with everyone else in a few moments. So thank you all for your great insights and presentations.
Thank you. See you all soon.
See you soon.
Yes, thank you. See you soon.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the eShop, and build your personalized AI for Good program. Let's shape the future of AI for Good.
The AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia, and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.
Hello, you.